The next ones we are going to evaluate basically a word problem where they're giving you the information in a formula and you have to plug the information into the formula, but of course you have to know how to get it into the calculator to get it to work, right? It says on number 4, if the rate of inflation is 3.9% per year, the future price, P of t in dollars, of a certain item can be modeled by the following exponential function, where t is the number of years from today. So, $3,000 would be the amount that was invested. 3.9% is the interest. They add 1 because you keep 100% plus the interest, and then it's to the t power. We want to find the current price of the item and the price 8 years from today. For the current price, you're using the time as 0, right? We haven't gone any time. It's right now, current time. So we're going to do 3,000, 1.039 to the 0 power, and it's going to look something sort of like that. That one you maybe don't even need your calculator for. Anything to the 0 power is 1. 1 times 3,000 means my current price is 3,000, right? I just put my money in there. It hasn't changed in value any. I haven't gotten any interest. 8 years from now. So we're going to do 3,000, 1.039 to the 8th power, and we're going to punch that into the calculator. We are going to round to the nearest dollar. Let's see if I have another calculator handy here. And what are we getting? $4,074. That's what I'm getting to. So 8 years from now, my $3,000 will be worth $4,074. The next one, it says a radioactive substance, uranium-240, has a half-life of 14 hours. The amount A of my sample of uranium-240 remaining in grams after T hours is given by the following exponential function. So here they're saying we started with 1,200 grams, we're doing the half-life, and then we have to do T over 14. On these ones on your calculator, because we have to follow the order of operations, you need to put an extra set of parentheses around your other fraction that you have as an exponent. So you're going to put the 1,200 parentheses 1/2 or 1 divided by 2 caret, and then the t is 11 hours, so 11 divided by 14, or you could use the fraction button either way. But you need that extra set of parentheses because otherwise it'd do the exponent before it did dividing, and so we have to make sure it does the dividing first. So, did you already figure that out? 696, and we're rounding to the nearest gram. Okay. So we started with 1,200 grams. Every 14 hours it's cutting it in half, cutting it in half, cutting it in half. So after 11 hours we have 696. We have a little more than half because we haven't even went our 14 hours yet. After 60 hours, so we're starting with our 1,200 grams. We have our half-life, and we are doing 60 hours out of every 14 hours that it cuts it in half. Which gives us 62. We round it off to the nearest gram. So number 6, the formula looks sort of the same thing. It says a radioactive substance, cesium-137, has a half-life of 30 years. The amount A of t in grams of a sample of cesium-137 remaining after 2 years is given by the following exponential function. So again, we are starting with 621 grams. it has a half-life of 30 years. And so on the first one, we're going to do 20 over 30. And we are getting 391. Again, we didn't quite make it to the 30 years, so we have a little more than half left over, right? Then we're going to do after 50 years. So 621, my half-life, and we're going to have 50 divided by 30. Did I punch that in wrong? Try that again. Veda, what'd you get?
Still trying.
You're still trying?
Yeah. I just keep punching too many things. 196.
196. What do you want the negative in front of your half?
Oh.
621, parentheses, and then 1/2, parentheses, caret key, and then parentheses, and we were doing 50 divided by 30. And 196.